Hi, I'm Adrian Collado, class of 2019. I'm an electrical engineering and computer science major.
Hi, I'm Zachary Cole, class of 2020, and I'm civil engineering.
Hi, I'm Diana Leo, class of 2021. I'm electrical engineering.
I'm Janine Rahman. I'm a pre-med biomedical engineering student, and I'm in the class of 2020.
And we're barely Brackish.
Currently, there are over 1 billion people in the world without access to potable water. Governments are struggling to meet the needs of their citizens and are desperately searching for new alternatives. Here at Barely Brackish, our mission is to provide an efficient, low-cost solution to this issue.
During our concept and design stage, we had two goals in mind: removal of impurities from the water as well as the extermination of any bacteria. To do this, we drafted several designs, of which the final approach we chose utilized the membrane, filter, and the induction heating unit.
The first subsystem of our design is responsible for water circulation and filtration. Starting with a reservoir filled with dirty, non-potable water, the water is pumped via a diaphragm pump that operates at 12 watts of power. The water is then forced through a filter membrane responsible for removing bad taste, odors, and particulate matter. The filtered water is then held in a holding reservoir.
The second subsystem of our design is the induction heating unit. The induction heating unit heats the water based on the principle of induction. Basically, what this means is you have a high frequency alternating current go through this coil, which then magnetically couples with this galvanized steel fitting to create heat in the galvanized fitting. This fitting will then heat up and will then heat water, which is stored within this center area, to boil this water. The water is going to get to about 190 degrees Fahrenheit, which will then kill any bacteria that is present in the water. Afterwards, the water will go through this valve and be deposited in the final reservoir. The third subsystem deals with the production of a DC voltage using an electric motor. As the shaft of the motor spins, it produces an electric current in these wires. The rotational energy is provided by a bicycle. As the bicycle wheel spins, it's attached using a gearing mechanism, which will then step up the number of turns for the electric motor to create a higher RPM.
Wait, yeah. Okay, now start. Yep.
Slow down.
In approximately 2 minutes, the water in the galvanized steel began to boil. At 212 degrees Fahrenheit, the majority of the bacteria will be eliminated from the post-membrane treated water. Using a TDS meter, which measures the total dissolved solids, we were able to demonstrate the pump's effectiveness of solid removal. As you can see here, the pump is successfully removing the sediment from the non-potable reservoir. Next, we show here the significant decrease in solids that the TDS meter detects. The final measurement shows yet another decrease in solid removal after the boiling is complete.
As our design development continues to evolve, the team plans to incorporate reverse osmosis, ultramembrane filtration, distillation, ion exchange, anion exchange, and dealkalizer methods. These would be used to remove all sorts of physical, chemical, inorganic, organic, radiological, and microbiological impurities from the water. Additionally, the team plans to redesign our product into a top-down structure that employs gravity and a handheld pump to circulate water throughout the system. With safety always being paramount in our decision making, a protective shielding is currently being designed to protect the user from being harmed, as well as to preserve the components. If you enjoyed this video, please give us a thumbs up and feel free to leave comments and suggestions for improvement.